to FIU Science. My name is Christopher Torres. I'm bringing you a story straight from a lab, one that could change the way you think about medicine. In a world where bacteria are becoming harder and harder to kill, scientists are trying to figure out ways to make sure our medicine still work to protect us, and which ones don't work anymore. And this is why at the center of the mission is a test called the Kirby Bauer test, also known as the diffusion test. It's one of the most common ways doctors and microbiologists measure how effective different antibiotics are against bacteria. The idea is simple. Bacteria are grown on a plate, and small paper discs soaked with antibiotics are placed on top. After a few days, scientists could see the results clearly. Circular zones where bacteria can't grow. Those zones are called zones of inhibition. The larger the circle means the stronger the antibiotic was. This method isn't just for science class though. It's used in hospitals and research labs all around the world. It helps doctors choose the right medicine to use for infections. To learn more about the Kirby Bauer test, let's go live to our correspondent, Nikole, reporting from the lab.
Thanks, Chris. Here in the lab, we recreated the Kirby Bauer test to find out which treatments were most effective at stopping two different types of bacteria growth. We started preparing two petri dishes, one with gram-positive bacteria, known as staph, and the other gram-negative bacteria, E. coli. These two types of bacteria have different defense mechanisms, which makes gram-negative bacteria, such as E. coli, to be more resistant to the treatments than gram-positive bacteria, known as staph. Next, we placed small discs soaked in 7 different treatments onto plates. We tested water, ampicillin, tetracycline, streptomycin, almond oil, tea tree oil, and eucalyptus oil. The plates were then incubated for over a week to allow the bacteria to grow. When we checked them the following week, we could see the results right away. Around some of the discs were clear circular areas. That's where the bacteria couldn't grow. Those are the zones of inhibition. We measured to determine how strong each treatment is. These zones of inhibition provide clarity as to the effect of the treatments at stopping bacteria growth. Clarity provides the foundation of informal and formal scientific communication, as it sets the standard for clearly understanding the topic. Now, what did we find? For that, let's go to Jorge and Amy, who have the results.
Thanks, Nikole. The results from our experiment were clear and honestly pretty fascinating. Before we get into that though, let's start with what didn't work. Our control water had zero effect because the bacteria was able to grow normally without showing any clear zone of inhibition at all, as we expected. Almond oil also had no antibacterial activity, which marks another 0 across the board. Now with antibiotics is when things got a little more interesting. The results showed that tetracycline had the largest impact, creating a 33 millimeter zone of inhibition for gram-positive bacteria, while creating a 31 millimeter zone for gram-negative bacteria, showing the strongest results overall. Ampicillin followed with 30 and 27 millimeters, while streptomycin followed with 21 and 20 millimeters. Then after that came the essential oils, and this is where the results were a little more surprising. Tea tree oil showed surprising results, nearly matching the antibiotics with a 30 millimeter zone for gram-positive and 24 millimeters for gram-negative bacteria. Now, eucalyptus oil was a little bit weaker, but it was also effective. It had 14 millimeters for gram-positive and 21 millimeters for gram-negative bacteria. So while antibiotics were clearly outperforming everything else, we found that certain natural remedies also have real antibacterial potential. These results line up with what the Kirby Bauer test is intended to do, which is give us a clear and visual way to determine what treatment is best comparing side by side.
Exactly, Jorge. That's what makes this test so important, not just in the lab, but in everyday life. The Kirby Bauer test gives doctors a simple, fast, and affordable way to figure out which antibiotics will actually help a patient. Without tests like this, doctors would have to guess. That's how antibiotics resistance spreads, as doctors aren't going to be able to provide the truth. Therefore, they wouldn't know what disease it is. Ultimately, honesty is the best policy, as it allows for limitations to be put in place and provides the acknowledgement that not all data is always accurate. When bacteria survives antibiotics for a long period of time, they adapt, becoming even harder to treat by the next time. By using this test, hospitals, scientists, and even students can track resistant trends and understand how tiny organisms react to different treatments. Our experiment also reminded us that science isn't just about the high-tech machineries. Sometimes it's about the simple ideas that have a big impact. These semi-clear circles on the dish represent the medicine which stops harmful bacteria from spreading, which is ultimately a valuable aspect to our everyday lives as it protects the health of our community. So, whether it's in a classroom, a hospital, or a global research lab, the Kirby Bio test remains one of biology's most practical and essential tools in the fight against infection. The Kirby Bio test shows that even in small experiments, it can make a big difference in understanding how we fight bacteria. It's a reminder that science isn't just happening somewhere far away, it's happening right here in every classroom and in every lab. Relevancy is so important and vital, as it allows for scientific data to serve a purpose and be valuable in our everyday lives and in our everyday decision-making actions.